Welcome to the debate. Today, we're doing something a little dangerous. We're asking you to stop trusting those textbook diagrams you were shown in third grade, the spinning balls, the curved space-time grids, and start trusting your own eyes. We're stripping away the complex equations to ask a really fundamental question about the reality we inhabit. Does the physical world actually behave like a spinning ball, or does it behave like a stationary plane?
It is a bold premise and one that cuts right to the very heart of the scientific method. We're looking at whether naturally observed phenomena, experiments you can literally perform on your kitchen table with a water bottle or a smartphone, disprove the heliocentric globe model, or if those experiments are being fundamentally misunderstood.
Exactly. We're grounding this discussion in a series of empirical experiments performed by a researcher known as Level-Headed William. This involves accelerometers, bubbles, balloons, as well as the analytical writings of the globe terminator regarding geometry and thermodynamics.
And while we both agree on the raw data collected in these experiments, right? The numbers on the screen are real, the movement of the bubbles is real. We fundamentally disagree on what that data actually implies.
Right. So I'll be arguing that true science must be observable and measurable by you, the individual. The direct sensor data proves the Earth is motionless and that what we call gravity is really just a misunderstanding of density, buoyancy, and structural vectors.
And I'll be arguing that while these experiments are entirely valid observations, they're being misinterpreted, mostly due to fallacious reasoning regarding frames of reference and definitions of force.
Let's jump right into our position statements then. I firmly believe that true science requires things to be observable, testable, and repeatable. We're looking at experiments where, say, a water bottle containing an air bubble is dropped in freefall. When this happens, the bubble stops floating up. It becomes spherical. It is, but it's more than a visual. It's hard data. Furthermore, we have source material showing a digital accelerometer reading exactly 0 g when dropped. Now, the literal definition of acceleration is a change in velocity over time caused by a force. If the sensor reads 0 force, there is no acceleration occurring. Therefore, this theory that we're being pulled by a magical force called gravity completely contradicts the direct measurement of weightlessness. The Earth is stationary, and objects fall due to density and electrostatic direction, not a pull from beneath.
I appreciate the commitment to empiricism. I really do. However, I come at it from a slightly different way. I acknowledge the accuracy of the raw data. The accelerometer does indeed read 0, and the bubble does indeed become spherical. But I believe you're conflating proper acceleration, which is what a sensor feels, with coordinate acceleration, which is a change in position relative to a reference frame.
Well, we'll definitely dig into those definitions shortly.
We have to, because my position is that the arguments presented in the globe terminator text often rely on logic that is sound in structure, specifically modus tollens, but false in its premises, particularly when we look at how an atmosphere behaves in a vacuum or how geometry works on a large scale. You're seeing a lack of contact force and calling it a lack of any force at all.
All right, let's move into the core of the discussion then. I want to start with that accelerometer because, frankly, this is the smoking gun. Level-Headed William performed an experiment using a phone with a digital accelerometer app. When the phone is at rest on the table, it reads 1 g. When he drops it, entering freefall, it reads 0 g.
Correct.
Now, citations from the source state clearly, no force in freefall means no acceleration. If the Earth were a massive ball pulling the object down with a gravitational force, the sensor should register that pull. It should register a force increasing or at least maintaining, definitely not vanishing to 0. Think about it. If I tie a rope around your waist and pull you, you feel the tug. If gravity is pulling the phone, why does the sensor read 0?
See, this is where I have to call out a specific logical error, which is the reification fallacy.
In what sense?
You're treating the lack of a contact force, which is the only thing an accelerometer measures, as a lack of gravitational force. To understand this, we have to look at how an accelerometer actually works. It isn't a gravity detector in some mystical sense. It measures internal stress. Imagine a tiny spring inside the phone with the weight on top of it.
Okay, a spring and a weight.
When the phone sits on the table, gravity tries to pull the weight down, but the table pushes the phone up. That squishes the spring. That squish is what the sensor reads as 1G. It is measuring the resistance of the table against the weight.
So it measures the fight against the fall.
Exactly. Now, when you drop the phone, you remove the table. The housing of the phone and the little weight inside are now falling at the exact same speed. The spring isn't squished anymore. It expands. The sensor reads 0 because it is yielding completely to gravity, not because gravity isn't there. It reads 0 because there isn't resistance.
I see why you think that, but let me give you a completely different perspective from the data itself. You're adding a theoretical layer to explain away the 0. In the source video, there's a vector tab on the app. When the phone is resting, the green vector line points down.
Indicating the direction of the weight?
Actually, no, the source argues the vector is inverted. When the experimenter pushes the phone left, the vector points right. When he pushes it right, the vector points left. It registers the reaction. So if the resting vector points down, that means the Earth is physically pushing the phone up.
That is quite an interesting interpretation of the software's display.
But it's consistent behavior, and here is the kicker. In free fall, that vector completely vanishes. It disappears. If gravity were a real force pulling it down, the vector should flip. It should point up to indicate a downward pull. But there is nothing. The source says this proves the force or vector of the Earth is up, not down, when resting, and non-existent when falling.
I have to warn against the false cause fallacy here. You are assuming the Earth pushes up mechanically, like an elevator floor rising, rather than the object pressing down due to its mass interacting with gravity. The vector vanishes in freefall because, again, the internal mechanism is in a state of equilibrium with the field pulling it. It's like a skydiver. They feel weightless before air resistance kicks in, but they are certainly accelerating toward the ground.
But if you cannot measure it, is it scientific? The source explicitly states, if the accelerometer was accelerating down in freefall, it would detect that acceleration by increasing from 1G. That is a perfectly logical expectation. If a force is acting on me, I should be able to measure it.
Only if the accelerometer measures coordinate acceleration, which it does not. It measures proper acceleration, the force relative to freefall. By definition, an object in freefall under gravity alone experiences 0 proper acceleration. Einstein actually described this as the happiest thought of his life, that a person falling from a roof feels no gravity. The experiment confirms general relativity, it doesn't disprove it.
I'm not convinced by that line of reasoning because it relies on just redefining acceleration to save the theory. But let's look at the behavior of matter, not just the sensor. Let's talk about buoyancy.
The water bottle and balloon experiment?
Yes, level-headed William uses a helium balloon in a box and also a slinky experiment. In the video, he has a helium balloon tethered inside a box. When it's on the table, the balloon floats up, stretching the string. Standard buoyancy.
Agreed. Helium is less dense than air.
But when he drops the box, the helium balloon stops rising. It just floats there in the middle of the box. The string goes slack. He also does this with a slinky. On the table, the slinky is stretched by its own weight. In freefall, the slinky retracts.
The observations are accurate.
Right, so the argument is that this proves buoyancy depends entirely on the support force of the Earth. The source says, buoyancy is not a cause of itself, it requires an external force. When the support is removed, the density gradient vanishes. Therefore, things fall due to density in a structural down vector, potentially electrostatic, not a pull from the center of a mass. If gravity were pulling the air and the balloon, the pressure difference should still exist.
This sounds incredibly like a straw man argument.
How so?
Because standard physics agrees with the observation completely. You are arguing against a version of physics that just doesn't exist. Standard physics states that buoyancy is caused by a pressure gradient in a fluid. That pressure gradient is caused by gravity pulling the fluid down, compressing the bottom layers more than the top.
Right, so we agree gravity supposedly causes the gradient in your model.
Yes, but here is the key. In freefall, the water or air in the box is accelerating downward at the same rate as the box. The fluid effectively becomes weightless relative to the container. Without that relative weight pressing down, there is no pressure gradient. Without a pressure gradient, there is no buoyancy. The experiment actually confirms the standard model. You cannot have buoyancy without the gravitational force creating the pressure difference against a resisting surface.
That is a compelling argument, though I would frame it very differently. You are saying gravity is still pulling, but the effects of gravity, buoyancy, and weight just disappear?
The effects involving internal stress and relative gradients disappear, yes.
Well, the source argues that weight is not a property of matter and requires an external force. If the weight vanishes, the cause of the weight, gravity, must not be acting on it. The source suggests leveling is the natural state, and up is the force. When you drop it, you remove the up force.
But if you simply removed an up force, the object would stay where it is. Inertia would keep it stationary. It wouldn't rush toward the ground. The fact that the box, the balloon, and the water all rush downward together suggests they're all being acted upon by something else.
Or they are seeking their density equilibrium because the electrostatic hold of the Earth is released. But let's look at the atmosphere itself. This leads us to the globe terminator source regarding thermodynamics.
The no vacuum of space argument?
Precisely. The source uses a very accessible analogy, the filet mignon and the cow.
I recall reading that one.
It's a question of necessary antecedents. To have a filet mignon, the consequent, you must have a cow, the antecedent. You cannot have the steak without the animal.
Logically sound so far.
The source applies this to gas pressure. The pressure of a gas is the force that the gas exerts on the walls of its container. This is standard chemistry. Therefore, if we have gas pressure, which we do, we are breathing it, there must be a container.
And the implication is?
Gas fills the volume of its container. If Earth has pressure, it must be a sealed container. But the globe model claims space is a vacuum. A vacuum attached to a pressurized system without a solid barrier violates the second law of thermodynamics. Entropy dictates gas will expand to fill the void. The source says, a gas will fill any container, but if the container is not sealed, the gas will escape.
I identify a category mistake in this reasoning.
Please explain.
The source insists a container must be a solid wall, like a tire or a tank. It categorizes the constraint of gas only as a physical barrier. However, a force field, like gravity, can act as a container.
Hold on, that is begging the question.
Excuse me?
You are accusing the source of a category mistake, but you are begging the question. You are assuming gravity exists to explain away the need for a physical container. But the existence of gravity is exactly what we are debating here. You cannot use the thing in dispute as the proof for why the impossible is happening.
That is a sharp pivot. However, we can look at the water pressure gradient experiment from level-headed William that we discussed earlier to prove this.
The one with the holes in the bottle?
Yes. The water squirts out further at the bottom than the top because of the weight of the water above it. The atmosphere works the exact same way. We observe a pressure gradient in the air, lower pressure at altitude, higher at sea level. This gradient proves the gas is being pulled down, piling up on itself. The container isn't a lid. It's the weight of the gas itself holding the lower layers down.
The source refutes that by asking, how can you have a pressure gradient without a container to begin with? You can't have a delta X, a change in pressure, without X, pressure. And X requires walls. The source is adamant, nature abhors a vacuum. If there was a vacuum next to our air should leave. The fact that it stays implies a physical barrier, a firmament, if you will.
Or it implies that the kinetic energy of the gas molecules isn't enough to reach escape velocity against the gravitational pull. But I see we are at an impasse on the literal definition of container.
Let's ground this in geometry then. We have talked about sensors and air. Let's talk about the land itself. The globe terminator presents a geometrical proof involving the Bolivian salt flats.
A beautiful location.
And a flat one? The source cites a study stating the Salar de Uyuni exhibits less than 1 meter of vertical relief over an area of 9,000 square kilometers.
That is incredibly flat.
It is a geometrical flat plane. Now, the source uses modus tollens. If the Earth is a sphere with a radius of 3,959 miles, proposition P, then there must be a measurable vertical drop of 781 meters over a 100-kilometer section, proposition Q.
Right, the standard curvature calculation.
Exactly. But the study shows not Q. We do not measure 781 meters of drop. We measure less than 1 meter. Therefore, not P. The Earth is not a sphere. The source calls this a violation of the law of non-contradiction. You cannot have a vertical drop of 781 meters and a flat plane of 1 meter in the exact same space.
This is where I must point out the equivocation fallacy on the word level.
Go on.
The source equates level with flat. On a sphere, level is a curve that is equidistant from the center of gravity. Water finds its level, meaning it conforms to that equipotential curve. The salt flats are flat in the sense that they follow the curvature of the Earth perfectly without local bumps. They are smooth, but they are not a tangent plane.
That really seems like wordplay to avoid the geometric reality. If I drive across a 100-kilometer salt flat, I am driving in a straight line, not arcing over a ball.
You are following the surface.
Let's apply this to flight then. The source, flight, the globe terminator, argues that a plane flying 500 miles per hour would need to descend 2,789 feet per minute to stay at altitude on a globe. That is the geometry of the curve.
That is the vertical drop argument again.
Pilots do not dip the nose, they fly level. If they were flying over a ball, they would fly off into space if they didn't constantly nose down. The source argues, everyone on the plane would know it if they were dropping 3,000 feet a minute.
But level in aviation means maintaining a constant altitude, a constant distance from the center of the Earth. Gravity constantly pulls the plane into that curve. The pilot doesn't need to dip the nose because the plane's down vector is constantly rotating with the Earth.
I see why you think that, but let me give you a different perspective using the sextant. The source, the sextant #globe debunker, argues this definitively. A sextant measures the angle between a star and the horizon.
Correct.
The source cites navigation texts, defining the angle of elevation as the angle from the horizontal.
Yes.
The argument is simple. Spheres have no horizontal plane. They have tangents. But a sextant requires a horizontal baseline to form a valid right triangle for trigonometry. If the Earth were a ball, the baseline would curve away, and the math wouldn't work. The fact that sextants work proves we are on a horizontal plane.
That is a misunderstanding of how the instrument works. The sextant measures the angle between the star and the visible horizon. Alternatively, bubble sextants use a spirit level which relies on gravity to establish the local vertical. The horizontal is simply the line perpendicular to that vertical.
But the source emphasizes that you can't have a geometrical flat plane on a sphere. If the baseline is curved, the angle of elevation is different. The source states you must have horizontal plane baselines to obtain elevation angles using a sextant. The success of celestial navigation is proof of the flat plane.
The difference between the tangent and the chord on the scale of a ship's sightline is negligible. But technically, the horizontal is the tangent at the observer's feet. The sextant measures the angle relative to that local frame. It does not require the entire Earth to be flat, only that the math is done relative to the observer's zenith.
But that brings us back to the start. If the math requires assuming a flat tangent to work, maybe the reality is the flat tangent. The globe terminator argues that the complexity of the globe model, using Coriolis effects, apparent deflections, and gravity that magically turns off in free fall, is just a way to hide the simple truth.
And I would argue that the simple truth fails to account for why the sun sets or why the stars rotate differently in the south, but we are focusing on the specific source material provided.
We are. And that material is compelling. It asks us to trust experiments anyone can do over complex theories.
It certainly encourages active engagement with the physical world.
To summarize my position, naturally observed phenomena favor the stationary plane. Water finds its level. Accelerometers read zero in free fall, proving no force is pulling them. Gases require containers, implying a firmament. And geometry demands a horizontal baseline for navigation. These aren't abstract equations, they are observable facts.
And to summarize mine, while the experiments are reproducible, the logic used to interpret them contains fundamental misunderstandings. The accelerometer measures contact force, not gravity. Buoyancy depends on the gradient caused by gravity, and level on a planetary scale is a curve, not a flat line. Complexity is not a sign of falsehood. It is a sign of a nuanced reality.
We definitely agree on the value of testing reality yourself.
Absolutely. Don't take our word for it.
Pick up a water bottle, download an accelerometer app, and look at the horizon. The debate lies in what you conclude from what you see.
Indeed. Thank you for joining the debate.
Thank you.